Hello students, in this video we are going to discuss some more concept of physical quantity and measurement. In this case, in this video we are going to discuss about density. What is density? Always remember that if we people say that 55 gram of any metal having volume 10 cc 10 centimeter cube. So what this statement 5 gram mass having volume 10 centimeter cube gives you the concept of density, and in this case we can say that 5 gram by 10 centimeter, this complete is the density. So what is density? Density is a mass per unit volume. Density is mass per unit volume is known, this physical quantity is known as your density. Hope this one is clear to you. The mass per unit volume of a substance is called its density, and generally if m is the mass of the body, v is the volume of the body, so m upon v is equals to your density d. Hope this one is clear to you. Now in Celsius unit, density is gram per centimeter cube, but in SI, especially in SI system, we have density unit is kilogram per meter cube. This is your SI system, SI unit system. Hope this one is clear to you. And then how we convert Celsius into SI? It's easiest for us, as we know that in Celsius density is 1 gram by 1 centimeter cube. Clear? 1 gram into 1 centimeter cube, and this we can express 1 gram by 1 centimeter into 1 centimeter into 1 centimeter. So we convert each gram and centimeter into kilogram and meter. How we convert? 1 gram equals to 1 upon 1000 kilogram, and 1 centimeter equals to 1 upon 100 meter. There are three. So hope this conversion is clear and you can easily see the conversion on board. Now come to this side. We can easily write down. I am solving this one now. So it's a 10 to the power 3 or 10 to the power 6 now in this case. 1 2 3 4 5 6. So we can write down 10 to the power 6 divided by 10 to the power 3. It's a 10 to the power 3. 10 to the power 3 kilogram per meter cube. It's a kilogram per meter cube. What does it mean? 1 gram per centimeter cube equals to 10 to the power 3 kilogram per meter cube. So hope density concept is clear to you. Now our next topic is how to determine the density of a solid by using a measuring cylinder. Determination of density of a solid by using a measuring cylinder. Suppose we have a measuring cylinder. Clear? This measuring cylinder is filled up to some height. We note down the, suppose it's up to this mark. There are some markings are there on the wall of the container. Now, so we note down this mark. Suppose this is your x centimeter cube. Now we tie that irregular solid and lowered inside the container. So what happened? Liquid rises upward and reach up to this point. Suppose it's a y centimeter cube. Clear? So from this we can find out, previously volume was x centimeter cube, now volume is y centimeter cube. So volume of a stone, volume of solid is y minus x centimeter cube. That is clear. We take out the body and find the mass. So we can easily find out the mass of the solid. Equals to m gram. So from this we can easily find out the density by using the formula of density. Density equals to m upon v, that is your m upon y minus x gram per centimeter cube. Likewise we can find out the density of a irregular solid. Move to the next topic. Now we are going to find out the density. I'm not writing here, I'm simply reading. Determination of density of a liquid by using a density bottle. What is the meaning of density bottle? A round bottom flask having capacity 100 ml. So this is your density bottle. We use this density bottle to find out the density of some unknown liquid. Remember, in previous experiment we discussed about some unknown solid. In this case we are going to find out the density of unknown liquid. So how we find out? First we take a density bottle, dry it from inner side and outer side by hot air. Students, remember what I am saying. All these things you must write in your copy point wise. First we take a density bottle, dry it from inside and outside, take the mass of the density bottle. This is the first part. First is wash the bottle. I am writing in short, in only keyword. Wash the bottle, wash and dry the bottle. Dry bottle by using hot air. Take the mass of the density bottle. Clear? Let it m gram. Hope this one is clear. We use physical balance to find out the mass. Then second, now we fill the bottle with distilled water. DISTILLED, distilled water wipe the excess water from outside, keep the cap. Always remember, in every time we use, whenever we find the mass, we keep the cap. So fill the bottle with distilled water, wipe from outside, mass with cover equals to m1 gram. Remember, each mass, whether this one or this one, is including the cover, including the stopper of the bottle. Now third, again empty the bottle, dry it from inside, fill the bottle with a liquid, wipe from outside and take the mass. Now this time mass equals to m2 gram. Hope this one is clear. Once again I am explaining you. In this experiment we have three parts. First part, we take the bottle, dry the bottle with hot air, keep the close the bottle with the stopper or lid and take the mass. Let the mass is m gram. Now remove that stopper, fill the bottle with distilled water, wipe the excess amount of water from the outer body of the density bottle, keep the stopper and take the mass. Now mass of empty bottle plus water or distilled water is equals to m1 gram. Clear? Empty bottle m gram, empty bottle plus water is m1 gram. Now again we empty the bottle, use hot air to remove all the distilled water, fill the bottle with liquid, take the mass of the liquid with including the bottle. So mass of the bottle plus liquid is m2 gram. So hope these three steps are clear. Now move to the next part. Now see the reduction part. Mass of empty bottle equals to m gram. Then again mass of bottle plus water m1 gram. Then mass of bottle plus liquid equals to m2 gram. Hope this one is clear. Now from this and this we can say mass of water equals to m1 minus m gram. This one is clear. Volume of 1 gram water equals to 1 centimeter cube, that we know. So m1 minus m gram water equals to m1 minus m centimeter cube. This is the volume of water. So similarly from this we can say volume of bottle is same volume of bottle is also same, it's m-1 minus m centimeter cube. Remember, volume of bottle and volume of water is same. This because this is the capacity of the density bottle, and if volume of bottle is m1 minus m centimeter cube, so volume of liquid is also m, liquid is also same, is m1 minus m centimeter cube. So what is the density? Density equals to mass of liquid. What is the mass of liquid? Mass of liquid is m2 minus m. Volume of liquid m1 minus m. It's a gram per centimeter cube. Remember, bottle plus liquid m2 gram, empty bottle m gram. So all mass of the liquid is m2 minus m. So m2 minus m, then volume is m1 minus m centimeter cube. So density is this one. Hope this one is clear to you. Now there are various numerical problem that we will discuss on next video. Let's discuss about some speed. What is speed? Speed is nothing, the rate of change of motion. Remember, the rate of change of motion is known as your speed. And this speed is given by, speed is always also equals to distance covered by time taken. Means what? We check that how many distance we covered and how many time it's required. When we divide each them, we have the speed, not speed, it's the speed. There are different types of speeds, but generally the SI system is your unit is meter per second. Sometimes we can express kilometer per hour also. There are different types of speed. One is your uniform speed, other is your non-uniform speed. What is the uniform speed? If change of motion is same, suppose a body is moving with a constant speed 10 km per hour for every hour, then this is known as your uniform speed. But if a body change first 10 km per hour, then due to traffic changes to 5 km per hour, again got a smooth speed, changes 15 km per hour. So this type of speed is known as your non-uniform speed. In uniform speed, speed is always same. There is no change, no ups and down. But in non-uniform speed, speed may vary. So this type of speed is known as your non-uniform speed. Now that's all for the explanation of this video. Numerical problem we will discuss in next video. All of you are requested to read what from the book also what I discuss it in this video. That's all for today. Thank you.